Take a look at these two hills. Let us say a bridge has to be built over them. Then you must know not only the horizontal distance separating the hills, but also the horizontal distances separating some of the points on the slopes of the two hills. Are these horizontal distances important? What are the methods to find out the horizontal distances on sloping grounds? How can we obtain the horizontal distances with these methods? Let us find out the answer by going through this module, Chaining on Sloping Grounds. Welcome. After completing this module, you will be able to state the importance of horizontal distance in plotting works, describe the two methods for finding out the horizontal distance on sloping ground, and determine the horizontal distance using the two methods. Let us take a look at the bridge again. As you can see, the pillars are spaced such that they bear the weight of the bridge only at those points where their support is essential. With the bridge in place between the two hills, it is very easy to identify where these points should be under the bridge, such as one point under the center of the bridge and two such points on either side of the central point at equal distances from it. But actually, what is constructed first? The pillars or the bridge? It is the pillars, correct? This means that the pillars must be constructed at certain points on the slopes, such that when they are raised to the height of the bridge, their tops become the bases which bear its weight at the essential support points. So, before beginning the construction of the pillars, a survey of the hills and their slopes must be completed. The survey map must contain the plotting work of the horizontal distances on the slopes, according to which the pillars for the bridge must be spaced. You have just seen an example of how knowledge of horizontal distances is important in plotting works. So remember, prior knowledge of horizontal distances in plotting works is important for proper planning of tasks that follow surveying. Now, there are two methods of finding out the horizontal distance on sloping grounds. The first is by chaining on sloping grounds, and the second is by using a clinometer. Let us first take a look at chaining on sloping ground. The process of chaining begins with the surveyor standing at a ranging rod at the top of the sloping ground and throwing the chain down the slope. Pick up the folds of the thrown chain and straighten it down the path of the slope. Return to the top of the slope. While another junior surveyor holds the handle of the chain against the ranging rod, pick up the chain length and slowly move backwards down the slope. When you come to a point on the slope beyond which you cannot hold the chain in the correct horizontal position, stop moving. At this point, run a plumb bob to the ground and mark the spot with chalk powder. This chain length is called one step. Let the surveyor count the number of chain links in the step. Now, let the other junior surveyor come down the slope to where the first step ended and pick up the chain. as before, move down the slope. You can call out the count of the links while the surveyor repeats them. Repeat these steps to calculate the lengths of subsequent steps on the slope until its bottom. To know the horizontal distance between the top and the bottom of the slope, you need to simply add up the lengths of all the steps. This procedure is called stepping because the imaginary lines connecting the chain lengths and the arrows on the ground resemble the steps on a staircase. So remember, stepping is the direct method for getting the horizontal distance on sloping grounds. The clinometer is basically a protractor with a string and a weight suspended from its center. Let us see how it is used to find out the horizontal distance on sloping ground. First, fix a ranging rod each at the top and the bottom of the slope. Let a surveyor stand at the upper ranging rod with a chain. Then, let the surveyor throw the chain down and also hold the handle against the bottom of the ranging rod. You must then straighten it in the chain and move down the slope, keeping the count of the chain links. When you reach the bottom of the slope, hold the chain taut against the bottom of the lower ranging rod and call out the count of the links to the surveyor. Let him repeat the same. Let this length be known as L. Point the clinometer to the top of the upper ranging rod so that the straight edge of the protractor lines up alongside and right under your line of sight. Observe the reading of the angle on the rounded edge of the protractor over which the string with the weight is passing. Call out the reading to the surveyor, who should repeat it. To know the angle between your line of sight and the horizontal, the surveyor subtracts this reading from 90 degrees. Let this angle be known as theta. To know the horizontal distance of the slope D, the surveyor applies the formula D is equal to L cos theta. This is how you can measure the horizontal distance on sloping ground using the clinometer. In this module, you have learned the importance of horizontal distance in plotting works, the two methods for getting the horizontal distance on sloping grounds, and how to determine the horizontal distance using the two methods. Prior knowledge of horizontal distances in plotting works is important for proper planning of construction tasks. The two methods of finding out the horizontal distances on sloping ground are by chaining and by using a clinometer. Stepping involves calculation of intermediate horizontal distances and adding them up. With a clinometer, the horizontal distance is calculated by measuring the sloping length and the angle of elevation.